Okay. Hello everyone. I'm Vivon, and in this webinar for LetUsTalkIt, we're going to be talking about the challenges of interplanetary colonization. For this topic, we'll be talking about the extreme dangers and perils of space, and we'll each be discussing a planet, moon, or some sort of land that we can colonize. In some cases, not even land. So we can begin with a table of contents. First, we will meet the panelists. Then we will see the planets that we have brought up, and we'll have a Q&A session where a few questions may be answered. Okay. Now let's meet our panelists. So, okay, Vish.
Hello everyone, my name is Vish, and I'll be talking about the difficulties of colonizing on Venus.
Okay, you're up. You're up.
Yeah. I'm Virat, and I'll talk about what could go wrong on our way to Mars. There are a lot of things. Let's see.
Great. Dave.
Hi, I'm Dave. Today I'm gonna talk about Mercury. We're also gonna talk about how there was no life on Mercury, but only 2 astronauts came to visit.
Okay, Mahadi.
Hi everyone, my name is Mahadi and I am an 8th grader in Ruther Middle School in Michigan. And today I'm going to be talking about Proxima b and what would happen if we colonized it.
Okay, and lastly, me. I'm Devon, and I'm going to be talking about Ganymede. Ganymede is an extremely dangerous planet. You definitely do not want to wrap yourself around. The picture is slightly inaccurate. Saturn shouldn't be in the background. Jupiter should be. And if you look close enough, this looks like the moon landing. So the whole entire picture is inaccurate. Okay, enough about the picture. Enough about meeting our panelists. Now, okay, across the sea of space, the stars are other suns. And this makes a lot of sense because sun just means star. Okay, Fish?
Like I said, I'll be talking about Venus. Anyway, next slide. Where is Venus? Venus is the second planet closest to the sun after Mercury, so it's likely to be hot. Next. Some basics about Venus. The climate, rain on Venus is made up of extremely corrosive sulfuric acid, which would severely burn any interstellar traveler's skin. Weather, it is a bit warmer, so there is slightly, well, that's wrong. Without oxygen, there is no ozone layer. Without an ozone layer, there's no protection for the water from solar ultraviolet UV radiation. And the surface temperature ranges from about 820 degrees to nearly 900 degrees Fahrenheit. The average surface temperature is 847 degrees Fahrenheit, hot enough to melt lead. Anyway, next slide. You can play the video.
Wait 1 second.
Venus is a place you would never want to visit. Often called Earth's twin because it's nearly equal in size and composition, Venus is a world of extremes. It's the hottest planet in the solar system, and it has the longest day. One day actually lasts longer than 1 year. So you could celebrate 2 birthdays on the same day. Reaching Venus only takes about 100 days, but scouting a landing site is impossible. The entire surface is permanently shrouded in clouds made of poisonous sulfur dioxide. As you descend through them, you'd be struck by 220-mile-per-hour winds. 30 miles down, the winds subside, and you'll enter a toxic haze. Venus's clouds rain sulfuric acid, but the atmosphere is so hot, the rain evaporates in midair, generating a haze of sulfuric acid over 10 miles thick. As you exit the haze, the temperature is 600 degrees Fahrenheit, and the pressure is 10 times greater than at sea level here on Earth. By the time you reach the surface, the pressure will be 92 times greater, the same pressure you'd feel half a mile under the oceans on Earth. And the temperature is a balmy 870 degrees Fahrenheit, hot enough to melt lead. Don't think that landing on Venus's North Pole will be any cooler. Venus barely tilts on its axis, making the entire surface the same temperature, day and night, year-round. Let's say you somehow find a way to survive down here. Exploring Venus would be extremely difficult. Venus's clouds reflect 90% of sunlight that hits them, so the surface is dimly lit, making it hard to see anything beyond 2 miles. Plus, you'll need a continuous supply of oxygen. Venus's atmosphere is 96% carbon dioxide, 3.5% nitrogen, and less than 1% carbon monoxide, argon, sulfur dioxide, and water vapor. Then there's the risk of cell damage and possible cancer. Venus has no magnetic field that we know of, so being bombarded by high-energy cosmic radiation is a major concern. One silver lining? You'd feel slightly lighter on Venus. Venus is 91% the mass of Earth, so you'd weigh about 10% less. Sound like a good time? Some people used to think Venus's clouds hid a tropical paradise underneath. It wasn't until the 20th century that spacecrafts unveiled its true, hellish nature. Sending humans to Venus is a long shot, but between 1970 to 1982, the former Soviet Union successfully landed 8 uncrewed spacecrafts on Venus. The longest any lasted was just 110 minutes. It's been over 30 years since we sent anything to explore Venus's surface, and some experts think we're long overdue.
And yeah, we'll move on to the next one. How will a colony look like on Venus? It would probably be a floating city because, like the video said, the surface temperature is real hot. You need a very strong air purifier to keep out the sulfuric acid vapor. And you'd also need it to be pressure resistant, heat resistant, and acid resistant for all the stuff in Venus's clouds. It would need to be crash proof with strong lights to see through, and it should be able to resist being blown around because, like, again, it has 220 mile per hour winds. And finally, it should have a radiation shield to keep the high energy out. That's all.
Okay, great, Fish. It's very interesting how Venus was thought as a paradise, and also interesting how it's almost impossible to land on. Okay, Dave, you can. Dave?
Okay, I'm gonna talk about the Mercury. Next slide. Where is Mercury? Mercury is the nearest planet to the sun, like this, and it's pretty small. Next slide. Why is Mercury the planet on the solar system? Mercury's planets on the solar system. Mercury is the smallest planet on the solar system because it has no significant atmosphere to stop impacts, so the planet is pockmarked with craters. Why is Mercury the closest planet to the sun? It's the closest planet to the sun because it circles the sun faster than all of the other planets. Next slide.
Yeah, Dave, it's not the closest planet to the sun because it circles it. It circles it faster because it's the closest. It is the closest because Mercury formed really close to the sun.
Oh. Wait. Is this the next slide?
Yeah.
Okay. When was Mercury born? Like other planets, Mercury was born about 4.5 billion years ago, and it was the first and smallest planet to ever be born, condensing of the swirling ring of dust and gas left over the sun's formation. Mercury became known as a terrestrial planet with a dense metallic core, a rocky mantle, and a solid crust. Next slide. Humans can't live on Mercury because scientists haven't believed there has ever been a life on Mercury, but 2 astronauts came to visit Mercury 1974 to 1975. The atmosphere on Mercury is almost non-existent. Mercury is inhospitable and sterile. Mercury doesn't have the temperature to allow liquid water to remain on its surface for long periods of time, and it needs that for life. You can play the video.
Here are 4 things you should know about the planet Mercury. Number 1. Mercury is the closest planet to the Sun at an average distance of 60 million kilometers, which is 39% of the average distance from the Earth to the Sun. Because it's so close to the Sun, 1 year on Mercury takes only about 88 Earth days. Number 2. Despite being so close to the Sun, with a temperature of up to 430 degrees, the planet is only the second hottest in the solar system, behind Venus. There, the atmospheric greenhouse effect is roasting the planet at 470 Celsius. Number 3. Since Pluto is no longer considered a planet, Mercury, which is not that much bigger than our own moon, is now the smallest planet in the solar system. In fact, Mercury is actually smaller than the largest moons of Jupiter and Saturn. Number 4. Mercury's gravity, being only 38% of that on Earth, is too weak to hold on to any significant atmosphere from being blown away by the solar winds. Like and subscribe for more.
Is this the end of my slides, or I still got more?
I think this is the end.
Here are
Yeah, you have one more slide. But quick correction. There are actually no astronauts that visited Mercury before. The only terrestrial piece of land outside the Earth we've ever explored is the moon.
Oh, okay. Here are 5 fun facts about Mercury. Number 1, Mercury has water and ice organics. Number 2, Mercury's magnetic field is different at its poles. Number 3, despite Mercury's magnetic field, it behaves similarly to Earth's. Fact number 4, Mercury's eccentric orbit help prove Albert Einstein's theory of relativity. Number 5, Mercury has no moons or rings.
Okay, great. Oh, yeah, you're done. You have anything else to say?
Thank you for listening to my presentation.
No, but that was very fun. I never actually knew that Mercury like had water. I thought it'd be way too hot for water to form, but it makes sense. I mean, ice could form at the poles, but how the water got there is pretty much a mystery. But maybe ice comets hit it. Ice asteroids, no one knows. Okay, here are some things that you need to know about the planet that I'm going. Okay, the piece of land that I'm going to be talking about. So it has like approximately 209 like quintillion. That's a lot of water. I mean, yeah, 209 septillion. And it has like 8 quadrillion kilograms of silicate rock. These are some pretty useful like things for the planet. I mean, moon. So I forgot to tell you what it is. It's actually Ganymede. Ganymede is the largest moon in the solar system and it has the most water of any single object in the liquid water in the solar system. It's a mystery how it can retain all this water. And it may be colonizable. So how will we get there? Well, some things are pretty hard to get to. This includes Ganymede. Getting there is going to be pretty hard. So how will we get there? Now, the Saturn V can actually get there. It's been proved a few times using calculations that the Saturn V is efficient enough. But the sad thing is that even though the Apollo can get there, the crew won't have enough supplies. The crew also need things like there's not enough food, water, and things like that to support them until the Ganymede trip. For the Ganymede trip.
Correction. Since they had big computers then, they could replace all the extra space with more supplies. It could
They
work
could.
out.
Almost all the blueprints have been destroyed, so we don't exactly know how to rebuild it. But lots of replicas, almost perfect, have been made. So we may be able to make a modified version for the Saturn V, maybe even a Saturn 6. The Saturn 6 could be a new launch vehicle that helps us get to Ganymede and beyond. Now, the stats are pretty cool, but I'm not going to mention them. So this is the Space Launch System, or SLS. It's Block 1B. So the SLS was made 2 times, Block 1 and Block 2. Block 1 was a lot simpler and was made for cargo, but this one is for crew. It has 2 solid rocket boosters, SRBs, and these will lift the rocket off the ground. It has a long rocket booster at the bottom, which will help it get to suborbital flight. There's an interstage, which is the fairing for the engines. These there will be a quick burn with the next stage. This will help them get to the moon. Then they said that they will use this as a docking port for attaching to the Deep Space Gateway, which is going to be another building that they're going to use to get to Mars. It's a space station for the moon. It's not actually going to be crewed. Only when they need it, they'll use it. So all this is just fuel and panels and stuff like that. Then there's the crew module, and this is the servicing module. This is how they will land, and this is the launch abort system, similar to the Apollo 11. This launch system makes sure that it detaches the crew module straight off the top of the rocket so that the crew can go to safety if something breaks. Okay. Now, SpaceX. Well, they're very ambitious about getting to Mars, but some tests have shown that we can even get to Ganymede with the Starship. The Starship was made for hundreds of people at a time, but if they remove quite some space and replace it with fuel and replace a few of the engines to be more efficient and powerful, then we can get a modified version of the Starship that can help us to get to Jupiter's moons. And this ship is big enough to store food for almost a few years. The Super Heavy is the booster that will help them take off. This will take them off, put them in orbit, and launch them to Ganymede. Note that this vehicle is completely reusable. It will come straight back to Earth. In full, everything will come back to it. So now, how will a colony look like? Well, we don't actually need radiation protection because most of the sun's radiation doesn't even get to Ganymede. But solar flares aren't a problem because Jupiter has an extremely powerful magnetic field, and this is so powerful that it even like ruptured a few of the signals that our satellites for Jupiter sent. So now radiation protection is not needed, and also solar wind is not a problem because it's the same exact thing. And it only needs cold protection. It's actually very cold down there. Giant heaters may be needed. There's no powerful or damaging weathers unlike Mars. This is the image in the background is a Mars colony, but that's unrealistic because of radiation protection. So a Mars colony will probably be buried underground. But this is very realistic for Ganymede because as everything they need is casual for a space station, maybe just a land station. So astronauts need to exercise, but they don't need to do it as much as normal astronauts. It's because the surface of Ganymede has the gravity half of that of Earth. And this means that they only need to exercise twice as much as a regular person. Okay, now spacesuits won't need to be too complicated because there's no hardships in extravehicular activity (EVA). And fuel cells, fusion, and geothermal energy may be the only sources of energy because solar energy is not viable and there's not much wind to really use. How will the vehicles look like? Well, following downward is an example of a engine, well, a plane. Now this is more than enough to start flying on Ganymede, just as an engine. Now, many vehicles will be airplanes. It's because there's so less gravity and so less atmospheric drag. So it's going to be easy flying planes, and plus planes are faster. Robots will probably be sent first because human colonization is pretty hard. These robots will make the colony using the resources found in Ganymede. Then food will be grown very easily because of how much water there is. Energy is not a problem because water can be split into hydrogen, which can be used for nuclear fuel. Okay, so that was a tough one. Lots of information to ingest. But it's explanatory now because I told you how easy it is to colonize Ganymede. The only hard part is just getting there. Awesome. Okay. Right.
Yeah. So, Mars. I chose Mars because, well, it's basically the trend. A lot of people are aiming toward it, and we're seeing a lot of solutions, very creative solutions, to how we could get to Mars. But let's see these employed. Now, Mars is not a joke at all. I mean, excluding the bars on Mars joke from Elon Musk. Other than that, no. Anyways, radiation. On Mars, there's an immense amount of radiation because there's no atmosphere or magnetosphere to protect us against the radiation that the sun is giving off. So the amount of radiation that splashes on us is 200 times more radiation once we're on Mars. One way we could solve this is if we put Martian rocks on us. This would probably dampen it a little bit, but we would still probably get a few dozens of times more radiation than a normal person, and that could easily get you cancer in no time. Now, temperature. Temperatures in Mars are quite extreme. They go to temperatures near negative, let's go at a top of usually like a top of negative 40 degrees Celsius to the coldest at a negative 253 degrees Celsius. So there are pretty high extremes in the amount of temperatures. We could live off of warmer areas, but we have to find other ways so that we can find hotter places. One thing is geothermal vents. So we found geothermal vents deep underground that we can make um, our colonies in, and that is a good idea. But except how you're supposed to get equipment and people above, and you would need to make elevators. That is not that hard, but you can't just send an elevator to Mars. You would have to make it on Mars itself, and then micrometeorites. This is not much of an issue in Mars itself, but in outer space, since they're going there for they'd be there for approximately 8 years because it takes a lot of time to get there and back and to do all the things that they need to do. So micrometeorites can blow holes in the equipment that may cause a failure. So we would have to work out something for micrometeorites. We could repel them with very powerful magnets, but that would deplete the electricity very quickly, and we could do nothing about it. We don't really have much of a solution for micrometeorites except a strong outer coating. Isolation. It's a long trip. Like I said, it would take over 8 years for a full mission to be complete. And you don't have to physically endure because the astronaut Scott Kelly has demonstrated that it's possible to live for a year. It was very tough for him, so physical endurance toward Mars is gonna be so hard because you would have to survive more than 4 times the amount of pain that Scott Kelly went through. He was on Mars for a super long time. I mean, he was in orbit in the ISS for a super long time. Anyways, now the body muscle that muscle and bone density lowers over time in outer space. In fact, if you stay there for near 10 years, then you would get 50% of your muscle and bone density would lower. So they would be, if this is a very big if they make it back, then the physical state they are in would require a lot of medical miracles to keep alive. This is very, very vital. It can be life threatening to everybody on board. Dust. Martian dust will be very dangerous to breathe, and it's also very toxic, and it's also very fine. It could get into equipment at any moment, and everything needs to be sealed shut, or else if dust gets in, then it could kill the astronauts because, of course, it's toxic and it could enter through anything. So these are all things that are not jokes, but literal facts. And next slide. Now we have the Space Launch System, or SLS for short. This is the Block 1B to get to Mars. And, well, this is how we'll get to Mars. This can get to Mars, but we would need more powerful rockets later on to put more things on Mars. If you go to the next slide, then you'll see that SpaceX can get us there. So we could get there with SpaceX missions like the Starship and the Super Heavy. They're really promising to be our next hope towards sending a lot of things. Of course, it would require a lot of time, effort, and money to employ a mission like this because the Starship itself with the Super Heavy and the Starship combined would take a long time. And it would also be very expensive. But at least it would be less expensive than the SLS missions. One cool fact, NASA actually took SpaceX's offer to go to the moon. That's not relevant. Anyways, so these are, I told you about the jokes, non-jokes I mean, and the two companies should I say, that can get us to Mars. Anyways, that was all.
Okay, for your information, NASA is not a company, but yeah, Mars is definitely not a joke. It's very dangerous. We definitely do not want to get stranded there or have anything to really do with it unless we want to colonize it, like you said. Okay, now Mahadi will be talking about colonizing Proxima b. It's a very far away planet, which is in the like closest solar system to us.
Thank you, Vivon. Hi, everyone. Today I'm going to be talking about Proxima b. On the slide, the GIF is not actually Earth, although similar, it is Proxima b. But what is it? Proxima Centauri b is an exoplanet orbiting the habitable zone of the red dwarf star Proxima Centauri, which is the closest star to the Sun and part of a triple star system. It is approximately 1.28 parsecs or 4.2 light years from Earth in the constellation Centaurus, making it and Proxima c the closest known exoplanets to the solar system. Now let's go on to the next slide and the basic info. Proxima b's climate consists of a dynamic ocean. We find that an ocean-covered Proxima b could have a much broader area of surface liquid water, but not at a much colder temperature than previously suggested, due to an ocean heat transport and/or depression of the freezing point. Proxima b could be inhabited, mostly open ocean planet with halophilic life. Now about the surface. Proxima Centauri, where the temperature is suitable for liquid water to exist on its surface. Researchers think that the exoplanet is tidally locked and its synchronous rotation with the star, meaning that one side is always facing the star and one side is always facing away, a light side and a dark side. In addition, it is unclear if Proxima b has an atmosphere. Now the location. Like I said before, it is an exoplanet orbiting in the habitable zone of the red dwarf star Proxima Centauri. The distance from the Earth is 4.24 light years. Now about the dangers. In Proxima Centauri's habitable zone, Proxima b encounters bouts of extreme ultraviolet radiation, hundreds of times greater than the Earth does from the Sun. That radiation generates enough energy to strip away not just the lightest molecules, hydrogen, but also over time heavier elements such as oxygen and nitrogen. Now, on the next slide, I'm going to be talking about the history and the future of Proxima b. When? The first indications of the exoplanet were found in 2013 by Mikko Tuomi of University of Hertfordshire from an archival observation data. To confirm the possible discovery, a team of astronomers launched the Pale Red Dot project in January 2016. It was officially discovered in 2016 as well. In the future, as of 2016, the lack of conclusive evidence for transits combining MOST and HAT-South photometry gives Proxima Centauri b only a 1.5% chance of being a transiting planet. The lack of transit events means alternative methods would likely be necessary to study the planet further. For example, it might be possible to image Proxima b and probe any atmosphere for signs of oxygen, water vapor, and methane by combining espresso and sphere on the VLT. Now on the next slide, I'm going to be talking about why can humans survive on it. The habitability of Proxima Centauri b has not been established, but the planet is subject to stellar wind pressures of more than 2,000 times those experienced from Earth from the solar wind. Absent a magnetic field, the radiation and stellar winds would likely blow away any atmosphere away, leaving the subsurface the only potential habitable location on the planet. The exoplanet is orbiting within the habitable zone of Proxima Centauri. With the correct planetary conditions and the atmospheric properties, liquid water may exist on the surface of the planet. Even though Proxima Centauri b is a habitable zone, the planet's habitability has been questioned because of the several potentially hazardous physical conditions. The exoplanet is close enough to its host star that it might be tidally locked. As I said before, when I was talking about the surface, if the planet's orbitable eccentricity is 0, this could result in synchronous rotation with one hot side permanently facing towards the star, while the opposite side is in permanent darkness and freezing cold. Another problem is that the flares released by Proxima Centauri could have eroded the atmosphere of the exoplanet. However, if Proxima b had a strong magnetic field, the flare activity of its parent star would not be a problem. Furthermore, recent evidence suggests that the largest flares of small stars, such as red dwarfs, primarily occur at high stellar latitudes. If Proxima b's orbit is close to equatorial, it might be less affected by the flare activity than previously thought. If water and the atmosphere are present, a far more habitable environment would result. A large portion of the planet may be habitable if it has an atmosphere thick enough to transfer heat to the side facing away from the star. If it has an atmosphere, stimulation suggests that the planet could have lost about as much of water that the Earth has due to the early irradiation in the first 100 to 200 million years after the planet's formation. Liquid water may be present only in the sunniest regions of the planet's surface in pools, either in an area in the hemisphere of the planet facing away from the star, or if the planet is in a 3-2 Resaunus rotation in the equatorial belt. All in all, astrophysicists consider the ability of Proxima Centauri b to retain water from its formation as the most crucial point in evaluating the planet's present habitability. The planet may be within reach of telescopes and techniques that could reveal more about its composition and atmosphere, if it has any. This exoplanet is the second most habitable planet to Earth, and if not for the distance and limited information. The future will bring many new discoveries, but for now, let's work on preserving our Earth. Thank you.
Great, Mahadi. I love how you talk about the dangers, but also the possibilities. It's fun to know that it retains water like our Earth. And those pictures also seem to show an Earth-like planet. We don't actually know, like you said. So let's just hope it's good. Q&A session. Let's begin. Okay, I have quite a few questions ready. So, what is the most dangerous planet to colonize? No, I'm not the reason I didn't say hardest planet to colonize is because Alpha Centauri, it's really hard to get there, but is it dangerous to colonize is the question. I'm thinking Venus, because definitely it's the hottest place on Earth. If it can melt lead, then what metals do we have to even stay on land? I know Vish said we could have air cities. Yeah.
I think Mercury because it's closest to the sun.
True, and plus we don't really have much magnetic radiation protection. But probably Venus, because what I meant by colonization is definitely landing on the surface of that planet or moon.
Yeah, I agree that it might be Venus because, as the video said, there's a lot of dangers from going onto the surface. So that would definitely make it a bigger risk.
Definitely. There's probably no other planet harder to um, like to take off from. No, I'm serious. Like it may be pretty easy to land on Venus because it has an atmosphere so thick that you don't even need a parachute or a thruster. Okay. Any Okay. So what are the easiest to colonize? This is a tough one. I would say Mars or Alpha Centauri. It doesn't really matter where it is, just the colonization is a problem. So maybe Alpha Centauri because of its water ability. It looks promising, but Mars is way closer to us. That's an advantage, but then again, it is pretty hostile in its own ways. Hello? Anybody there?
Yes.
Okay, so how will we get to these planets? Me and my brother already said that SpaceX Starship and the SLS will be great to getting to Ganymede and Mars. And the Apollo and a advanced, more modified version of the Saturn V could also get us to Ganymede.
It's amazing how the Apollo 11 has that strength. We could even add boosters. Remember, the Apollo 11 didn't have any booster stages.
Yeah, it didn't have any boosters. It was a simple rocket. And if it had boosters, if it had all the complex technology that we have now, it would be getting to Mars, like literally. And if it had the budget of today, well, that's a problem because it's Obama's fault that he cut the budgets. But it should be fine. So, how will we get to Alpha Centauri? Like, it's a few light years away. So in a book, I read about nuclear spaceships, and these can accelerate to approximately 1% the speed of light. And this means that it'll take at least 400 years to get to Alpha Centauri. So the crew has to be multi-generational. So it may actually be possible to get to Alpha Centauri. It's just too dangerous to try. Okay. Are we ready to undertake some of these colonizations right now? I'm probably thinking Mars because the technology's already been developed and almost everything is already built. Just Ganymede, Venus, and Mercury are the problem because nobody has built any rockets specifically for these things that allows us to help colonize them. Anybody has any other opinion? Okay. Can the earthly problems be solved in time to help us build these space colonies? Like, we have lots of problems here down on Earth. So can we fix them before we get to somewhere that we don't even know that we can save?
I feel like a lot of people are now like considering the possibility to abandon Earth and go to other planets to colonize that. And I feel like we're not really like spending time on the problems we have here. So we gotta like think about our Earth before we think about going to Mars or Mercury or Venus or anything like that.
That makes a lot of sense, Mahadi. We definitely need to solve all the problems, but will we do it in time? I mean, what happens if we take too long? What happens if we're stranded and humans die? We haven't even lasted for 200,000 years. That's not even a million years. Compared to the universe, we're a speck, we're a grain of sand in the Earth's lot.
Well, I definitely think that time is gonna run out because I feel like nobody's paying attention to how our Earth is actually crumbling, and rather just like our human species and how we can like make life easier. But what if there isn't a life, you know? So we definitely got to spend more time on that.
Great. Okay, here comes the fun one. What about space countries, rebellion, and space war? I know Vish has some ideas. Pew pew. Vish? Okay,
Yeah.
what you do?
Huh? Yeah, I'm here.
I said, how about space rebellion, space war, and space countries? Do you have any opinion on that?
Hmm?
You have an
Can't hear
opinion
you.
on
Can you repeat?
you have an opinion on space war, space colonies, and stuff like that.
Space wars, if there weren't to be space wars, I mean, people's technology would evolve like hecaton. So
Yeah,
it'll
that makes
probably be enough to obliterate a planet or a solar system, maybe.
that makes a lot of sense. World War II has given us almost all the technologies we use today, which is kind of ironic. It killed many, but it helped many later on. Now, if space war happens, it might as well be for a good cause. But
Well, it would rather be more of a train wreck.
a train wreck, definitely. But the technologies that get passed on might be way better than the ones we have now. Maybe we'll be able to accelerate to 10% the speed of light.
Or maybe a space train wreck.
The space train wreck. That sounds awesome. Okay. Now, what countries and space agencies are ready for these tasks? Well, I already see NASA and USA in the spot. SpaceX is not called a space agency, is it? It's just a private company, right? Okay. That question doesn't really make sense. We can move on. So, are private investors ready? They're more than ready. Look at Elon Musk. Okay. So, are there any other private investors that are going to help us with this? Well, probably Jeff Bezos. He owns the richest company on earth, Amazon. Amazon has more than enough money to refund the Apollo program. And this is why they're that insane. They're ready to go to the moon already. They just need to spend more money into rocketry. And they already started one. They took over a company called Blue Origin to explore space. Now, what technological advancements must be made? Anyone? Anyone? Hello? Well, we'll definitely have to improve safety technology. Like, what happens if cargo doesn't get to the colonies? They might die. And also rocket technology. We need to get to planets faster. Like, we can't spend more time getting there than the time we spend on there, right?
I'm thinking definitely landing systems. We don't have the perfect landing systems like We have landing legs and parachutes and thrusters, but they're not exactly perfect. There's a lot of chance of failure. In fact, Apollo 11 almost ran out of fuel in the wrong place, and its engines got dusted up.
True. And plus, they jammed a lever, which let's hope that doesn't happen later. Now, that is all. We had a pretty long Q&A session this time. That's good. So, right now, we're going to be taking up a quick some time to talk about the next topic. If you want, then you can join in for Zoom link. So, we're done. See you next Saturday, or if you're coming back, then on Tuesday. Well, next Saturday. Yep. Okay, all panelists stay in the meeting.